So to begin finding the equation of the ellipse, we use these values to determine the location of the center and the other focus. So since we know that the ellipse is vertical, we know that the center and both foci will have the same x value because all of them lie on a single major axis. Now for the center, we have the y value will be 8 because we are given the covertice of 6, 8, which is at a 90-degree angle to the major axis and therefore represents the end of the minor axis. And this will have the same y value as the center. So from this, we conclude that the point of the center is negative 7, 8. Now in order to determine the y value of the second foci, we each need to find the distance from the first foci to the center, as the distance from the second foci to the center will be the same. And this distance is 1, so we know that the second foci will be located at negative 7, 7. Now, to help in finding the length of the major axis, we need to find the distance from the foci to the known vertice, because the sum of that distance will equal the distance of the foci to the edge of the major axis. This is possible because, as a rule, the sum of the distances from both foci to any point on the ellipse will always be constant. Now, in order to find this distance, we use the Pythagorean theorem. As we know, the distance from the center to the foci, or the height, is 1, and we know that the distance from the center to the covertice, or the length, is 13. And so by doing this, we find the distance from both foci to any point on the ellipse is 2 times the square root of 170. So now, the value we are searching for, as we see in this ellipse, is the value of AE, as using that in the distance from the center to the foci will equal the length of the semi-major axis. And we can find this value by using the fact that BE is equal to AE plus 2. And we can substitute that in to solve for the value of the semi-major axis. So we end up finding out by doing this that the value of AE is the square root of 170 minus 1, and the value of the semi-major axis, then if we add in that 1 from A to the center, will be the square root of 170. So finally, the last piece of the puzzle to make the equation of the ellipse is the semi-minor axis, which we simply find by finding the distance from the covertice to the center, which ends up being 13. So now we just plug in the values into the equation of the ellipse, with HK representing the center of the ellipse, or negative 7, 8, B representing the length of the horizontal semi-minor axis, or 13, and A representing the length of the vertical semi-major axis, or the square root of 170, and we end up with this equation for the ellipse.